It's 10 o'clock. Hi, everybody. My name is Edward, and I'm a scientist and developer here at LoSci for the LS30 lab with Kevin. And I work with Curtis and Mark Heiner and Gabe Selzer. And oh, Ed, okay, sorry, there was some information here. Yeah, we work on Fiji ImageJ. So I'm gonna try to keep an eye on messages and the QA panel, which I don't see here, but I will figure that out. So if there's a message that I don't see in the QA panel, which I may not be able to get to, please just go ahead and post it in the chat to me and I'll try to get to those. So anyways, so we're going to today talk about segmentation and scripting with Fiji ImageJ. So before we start, there's some workshop materials primarily. If you can navigate to this link here and download this data set, we're going to work with that at the near the end of my little slideshow. If you don't have to get that, so you can still follow along without that, but if you have the opportunity to grab that, you can. Okay, so let's continue on. Yeah, okay. So also we have some scripts that I'm going to show you that you can use. So most of them are here. Sorry, you don't need this extra bit. If you just go to github.com L11s and then Fiji scripts, you'll see all kinds of different things that we can play with. We're going to use just 2 scripts from that, but there are other scripts that you can go and take a peek at. And other resources that are great for you. Oh, thank you for Gabe for that link. Other great resources are the wiki, so ImageJ.net. I'm going to show you a little bit of that if you need to search for something. I still find the old ImageJ documentation site still very, very useful, and that's migrated to ImageJ.net. So you just need to put an extra slash there, IJ, and you'll get to the old documentation. And I can't recommend this enough. Peter Bankhead's bioimage analysis blog is absolutely awesome. It's a wonderful resource. Do yourself a favor if you haven't checked it out. Go check it out and just look at filters. Filters are awesome. We're going to use some of his techniques actually, or some of the. I have a snippet from his blog later on in the workshop here. Okay, so what are we doing today? Today we're going to talk about segmentation in Fiji. So this presumes that you already know what Fiji is, you have it kind of installed, and you know how to open up an image and look around. So we're going to work with classic image segmentation first, and then I'll show you some advanced plugins that you can play with to segment your images. I think it's really important. I think it'd be remiss if we just segmented it without actually doing image processing, unless you have ultra clean data, which is fantastic if you do. I don't typically. So, that means I have to know how to do some image processing to extract some features and get a better result from my segmentation pipelines. So there's a lot of different ways you can do that. I just want to show you 2, which are my favorite, which are Gaussian blur extractions or Gaussian blur subtractions, and Richardson-Lucy total variation deconvolution, which I think are quite nice. And then finally, we'll end this with learning the macro recorder and scripting basics and actually writing a script. So I only got like 20 slides here, so most of this is actually going to be looking at the desktop, where we're going to be working with Fiji. So in between these slides, I've got little spots here to jump out to the desktop so we can actually see how it works. Okay. So classic segmentation, what does that really mean? So, you're usually going to have some kind of input image, probably grayscale, like the blobs example in Fiji. And the process more or less is this. You open it up, you select a threshold that looks good to you, whether that's a manual one or you're using one of the automated thresholders. You apply that threshold, which converts that image into a binary image, which means there's only 2 values. In this case, it would be 0, and then the maximum value of an 8-bit image, which is 255 or 256. So there's only 2 values here. And then after that, you can use, in Fiji, analyze particles, which is just a front end for this operation called connected component analysis, or CCA. And what that does is it moves through the image and it connects pixels that are in the neighborhood with each other. And that's how you can find objects. So doing that, actually, I should get my little, here we go, laser pointer. Here we go. So doing that, we get to this stage here. So we've opened up the image, we select the threshold, we apply it, we're going to detect some objects, and the Analyze Particles plugin is nice because you can do size filtering and some other options here like circularity. And then most importantly, you want to make sure you add that to the Rueden manager, and then you find the objects. And this is the last step here. It is kind of what I feel like a lot of people don't quite capture, is that you want to transfer those ROIs onto your original image so that you can actually get the measurements, maybe like the mean intensity of your regions of interest or things like that. So that's generally the flow of segmentation, and it can take different forms. So for example, if you have an input image here and you're using something cool and fancy like Cellpose, you're not really selecting any kind of threshold. It's going to spit out a mask for you, something kind of like this, that you can then apply to your image and examine it. So, and the other thing I want to say here is that this process also has image processing, right? So before you get to this threshold or component, maybe you tried all the thresholders and they all kind of aren't that great because they're still capturing too much of the background. Well, that means now you have to do some image processing, which would happen, in between this stage 1 and stage 2 of segmenting. Okay, so what are some fancy advanced ways that are not classic that you can do in Fiji? So one of them is Stardist. It uses star distribution to identify blobby circular objects. And here's just a little GIF on how that looks. And it works really well, honestly. Here's a picture of nuclei, and I just opened up the plugin. I didn't select or I modify anything, and I hit go, and it spits out, to my eye, a pretty good segmentation of all of the nuclei here, and then also add some to the ROI manager, which again, I can then take those ROIs, apply them to the input image, and do measurements on my original data. Another really good one that I want to shout out is LabKit, and this is using pixel classification to identify or segment the background from the foreground. So here you can see that you select pixels with a little cursor and saying this is the background, and then you do the same for what you think is the foreground, in this case, the same nuclei image. And so I'll let that run again. So there you go, I do that, and then I select this other thing, say that's the foreground, and you just let it go. And it produces a result like that, which is really, really quite nice. So if you haven't played with that, give that a whirl. Maybe that might help with your current segmentation issue, but it's worth a try. And importantly, this works on 2D and 3D data. The Stardist plugin I just showed you before, I believe is only in Fiji 2D. You would have to go to Python land, I believe, to get to 3D functions there. And last one here before I want to do a little demo and show you how we can do some classic segmentation is TrackMate. Use it with Cellpose. So Cellpose is a wonderful segmenter that uses optical flow and all kinds of cool things that I like to think I understand, but I don't fully, to segment not just nuclear shapes, but actual cell amorphous shapes. And Jean-Yves, the main developer behind TrackMate, was able to include that into TrackMate 7, I believe. And you have to go into the Fiji update sites to check just TrackMate dash Cellpose to get this. But after you get that hooked up, it'll find Cellpose for you, and then you get these really cool segmentations of cells coupled with the trackingness of TrackMate, which is really, really, really awesome. Okay, so before I move into this next section, I just want to show you what does this process look like for doing classic segmentation with the blobs example. And it'll take just a second here. So hopefully you can still see my desktop. No one's going to say anything, which is fine. So if you can't see it, I will see some people say stuff. So let's open up the blob example. So if you go to File, Samples, and you do blobs, and I'm going to do my best not to use hotkeys here. I like those a lot, but I know you can't see what I'm doing, and Windows will start popping up. So if something happens like that, just let me know, and I'll try to go back and tell you where it is in the menu. So if you open up blobs, here we go. And I'm going to make this a little bigger. All right. So now imagine this is your nuclei or something. Let's go ahead and threshold it. So if you go to Analyze, sorry, I want to go to image adjust and its threshold. So I'm gonna go ahead, select threshold, and I get this guy, which can be a little confusing. So what it's doing right now is it's picked up the dark background and ignoring the thing that I want, which are the blobs. So I'm gonna uncheck that. I'll get my blobs. And now through here, I can, this little pull down, I can see all of the different automatic or algorithmic thresholders that I can play with. So you can cycle through these. I'm just hitting the down key on the arrow here. And I know it doesn't look like much is changing, but when we look at more sophisticated data, you will see that you get quite a different spread of thresholds here. So I'm just gonna pick one of them, like Otsu. We go ahead and hit apply. And now I have this binary image. And I know it's binary because it looks that way, but if you examine it with the cursor, I can see that I got a 0 value here. So if you look at the toolbar, it says 0 there, and then 255 where the blob is. Awesome. So now I've got this, but what do I do? Ideally, I should have duplicated my input image, but I know it's a sample image. So I'm going to open up another copy here. So here's that guy. So with this, I'm going to go ahead and use analyze particles, which is the most likely way that you're going to first experiment with segmenting. So if you go to analyze particles, you get this cool little window. And you can do a couple things here. You could leave this blank and won't filter based on size, or you can select the area of the object that you want to filter by. So maybe you want to say, it's got to be 10 pixels squared at minimum. So really tiny, small speckles can be excluded, which might be very helpful. Down here, you can select all kinds of different outputs. You choose whatever you like. I'll just select overlay as an example. And more importantly, you have other options here, but the most important one is to make sure you have add to manager so that the regions of interest that are found get added to the Rueden manager. So if I hit OK, we'll see now that this has identified all these different kinds of blobs. You can see they've given little numbers. And then I have the Rueden manager that's populated. So if I go back to this other input image here, the blobs, and this is kind of nuanced here. If you select the Rueden manager and you just toggle the show all, it will transfer those ROIs to the other image. So now I can hit the measure button and look at that. I get all of my measurements from this image. If I didn't do that, and I'm gonna hit not save here, and I'm gonna select this first one and hit measure, you'll see that all of my my measurements are the maximum 255 because it's actually measuring the mean intensity from the binary image, which is not what we want. We want the intensity from the blobs image. Okay, so that's just a quick little run through of what that looks like generally. And so we're going to be doing this in a scripted manner at the end, where we're going to hopefully find some puncta and make a nice little results table. Okay, so let's get back to my slides here. And let me do a little check on questions. No questions yet. Cool. So let's move into what kind of image processing you might want to do to help your segmenting. And both of these examples here, so we're going to do a Gaussian blur, feature extraction or subtraction or something like that. I'm not quite sure what to call it. And a Richardson-Lucy total variation deconvolution. Now, both of these have scripts. So from this, you'll be able to walk away with scripts that you can put in Fiji and run it on any kind of data that you guys have and play with it, okay? So as a sample data, just kind of get this concept through, we're going to do a Gaussian blur subtraction on some data that Sophia Romero gave to me. I used to work with her, and she studies, or used to study, HPV. And she wanted to identify puncta in a cell that was very large and had a lot of haziness to it. So let me show you that. So here is the data set that she gave me, right? And it's 100x, and it's not volume. It's just X, it's a 2D with one channel. And she wants to be able to segment all these little different guys here, these little puncta, which can be a real challenge. If you're just using a classic thresholder, you're almost certainly going to just fail without any kind of image processing. And I want to show you what it looks like doing the Gaussian blur and then what the result is. So here is the input image. And then here I've done the Gaussian blur. In this case, I've selected a sigma of 5. And I know, like, why did you do that? Don't worry, we're going to do this live. And then we're going to talk about how do you select a good Gaussian? And it's a field. But if you select a Gaussian blur like this, and then you subtract it from the input image, what you get left behind are all of the peaks from the puncta. And now I removed a bunch of the haze from, I don't know, some out of focus light or something in a different channel. So what does that mean for thresholding? So if I look at the input image that I did not do anything with, right? And I apply the threshold, and I believe this is the triangle threshold, which works in my experience pretty well with puncta. You can see I'm getting the entire thing. There's no way I'm going to find any individual puncta in this image here. Oops, sorry. I should get my cursor. There we go. So yeah, there's no way I can get anything here, right? But if I do that same threshold on the Gaussian subtraction, I can see that I'm doing much better at obtaining the objects of interest. Maybe I'm not getting all of them, but I'm getting most of them. So if we put this together, so here's the input image, here's that mask, and then here is that mask overlaid on that input image. You can see it's cut through quite a bit. And so now, right, I've made this mask. This is what would be segmented, right? So we can then use that mask like we did with the blobs to measure the shape of the puncta, the intensity, Farrett's diameter, other kind of shape descriptors or geometries of the puncta here. So how does this all working? What's going on? And then let's go look at it, okay? So what's happening here? This is a little snippet I got from Peter's blog. So like I said, go check it out. It's fantastic. And what we're doing here is kind of like a very easy way to do well, let me put it this way. What we're doing is you're taking the input image here, and when you apply a Gaussian, you are suppressing noise. And depending on how large that Gaussian is, you get more or less suppression. So if we look at the original image here, we can see all the noise through this line plot. And if we do a Gaussian of 2, we can see the peaks are still there, but it's smooth. And of course, if we do a larger Gaussian, it's even smoother. And so the whole point that you're trying to, what the idea here is you're trying to extract only the features you want to remove from the input image. So it's a subtractive type of image processing. So you get all of this haziness here, but you leave the puncta behind, for example, and then you subtract that out, you should get only the puncta. The common way I think you're probably going to experience this is difference of Gaussian, so DOG or DOG, and that's when you have two Gaussians and you have a small one, a large one, and you subtract from the input image, and you're left with a valley of structures. I personally like to only subtract one Gaussian, and it seems to work well for me. You can play around with that and see what works best for your data. So let's do this, and let's see what that looks like. And then we have a script that we can run for that as well. So I'm going to open up our sample data. Give me a second here and get rid of all the stuff. And hopefully you had a chance to download that. So this is the sample data. It is a volume image of HeLa cells infected with HIV. I used to be a virologist, and I'm stained for this viral protein called VIF. And here I'm going to open up a couple panels here, which is to adjust the color. So adjust color balance, and then I also want the channels tool because I want to put this in color mode, so we only see one channel at a time. So there's the two channels, and then here is the volume, right? So what we're going to do is we're going to extract this first channel and then do a Gaussian blur subtraction on it. And then I'm going to show you a script that does that, okay? So let's do that real quick. If you do duplicate, is the easiest way in my experience. If you go to image duplicate, I only want channel 1, and we're going to call it just VIF. And I do want the whole volume, so it's okay. So now I have just that. And I personally think that grayscale is the best scale. So we're going to go to grayscale so we can see this. And there we go, right? So if I just cold try to threshold this, and if I go to, what is it, adjust and do threshold, and I have a dark background, and I go to triangle, I can see that I'm not going to be able to get anything, right? That looks pretty rough. So let's do a Gaussian blur subtraction on this. I'm going to go ahead and hit auto here to get the color back. So I'm going to duplicate this, and I'm going to call it Gauss. And I did the hotkey there, so sorry, but that's an image duplicate. So here we go. So I have a duplicate of this. and I'm going to blur this image. So I go to Process, let's see, Filters, Gaussian Blur. And if you hit Preview, you can see what you're blurring. So now here's the trick. How do you know how to do this? I start blurring it, right? So I look at puncta that I want to maybe extract, and I want to blur this just enough so I don't see them anymore. And what you're left behind is the haze you're going to remove, right? So if I say 4, that's quite not good enough. Maybe 5, 6, 7, 8. Let's do 8.5. I can still see some puncta, but I'm willing to lose some of those. So let's go ahead and apply that and hit yes. So now this whole stack has been blurred. And now what I want to do is subtract this image from this image. So you can do that using the image calculator. So you go image, process, image calculator, and you get this thing, which is my favorite thing in Fiji ImageJ, is the image calculator. And so I'm going to select the first image being VIF. I'm going to select subtract. And the second image I'm going to select is Gauss. And then this is real important, you want to make sure you do 32-bit float. So hopefully you went to Helen's intro workshop where she talked about that. We're going to subtract. So that means there are going to be some negative values here potentially. So you want to make sure you have a container that can, or an image type that can support negative values. Otherwise, you might get cut off looking kind of image, might not look great. So we'll hit OK here, hit yes, and then boom. So now this looks a little dark. I'm going to go ahead and adjust this. There's my image. Look at that, right? So it looks like we just have all the dots. If I zoom in here a little bit, it's not perfect, but it'll be much easier to apply a threshold to this. So let's see. If I go to image, process, image, adjust threshold. Here we go. And here's a triangle threshold. So it saved my settings. I can see now that instead of getting the entire cell, which was impossible, now I have this, which looks a lot easier to potentially work with. It's not perfect still, right? So I can still see I got single pixels and things, and you can do filtering for that to improve your segmentation. Okay, so wow, that's a lot of stuff you have to do. Ed, can I do it as a script? The answer is yes. So I'm going to bring the script editor over here, and you can get that very easily. So let's close up some of these images because we don't need these anymore. So here's this image. And this is in that link. So the Fiji scripts GitHub repo there. So here's the script. We'll break this down in a second, but I just want to show you what this looks like. And I'm going to give you a little primer. This little stuff up here is what we call the script parameters. It creates this nice little GUI for us so that we can input some values. And then after that, it hands off all of those values to the code, and it works. So let's run that same thing we just did with the script. So if we run it now, and forgive me, it likes to shoot these little windows off to a different screen. But here now I can see that I have two things, my input image and my sigma. So I'm going to select VIF as my input image. And I had to use 7.5 last time as a value. So I'm going to go ahead and select this to be 8, because that's what we did this time, and hit OK. So give that a second. And hopefully it's doing something. And if you're ever not too sure if it's doing something, you can always type mem in search, and you'll get the memory monitor, and this will dance around. So, maybe you don't get the little taskbar here or progress bar, but this will dance around. Okay, so there we go. So now we have this same image that I showed you before done in one step with the script. Okay, cool. Let's move on. And in the interest of time, I'm going to talk about deconvolution real quick, but and I'm going to show you where the script is, but we're not going to run it because I want to make a script with you guys. Okay, so real quick, Fiji has deconvolution in it. It's implemented by ImageJ ops, and it's got two kinds: the regular variety and the total variation kind, which I think is honestly probably what you should use. I don't yet have a good reason why you shouldn't use it. And here's what it looks like. So here's the input image. Here's a blurred, synthetically blurred image. The original implementation, which is in Lucy. And then when you include total variation, which has some regularization factors to help with noise that's amplified during the process, you kind of get not kind of, you do get better lateral and axial resolution. So how does it all work? I'm going to skip all this, but you need a point spread function, and you can check out these slides later. They're online, and also pause this video and find out read those details. But ImageJ ops is able to create the synthetic point spread function for you. So here's what that looks like in Fiji. I'm going to show you the script. We're not going to run it, but I just want to show you the input. And here's, the input image. You select some values, it deconvolves it, and then it spits it out. So let's take a quick little look at that. And I'm just going to open it up. So go File, Open, and we're going to go to where that lives, here, Deconvolution. So here we go. There we go. So if you hit run, you'll get this cool little window here. So give this a try. You're going to select the image you want, the iterations, and then all the specific details about your image, numerical aperture, things like that. And it will do deconvolution for you. That's another way that you can potentially get something like the puncta here in these dots, or in this image, they are dots. Okay, so let's move on and go more into scripting, playing with the macro recorder, and then let's together write a script. So scripting with Fiji and automating things. So what are scripts? What can you do? So why use scripts, actually? Scripts are great for reproducible science. You can document your work, obviously. It records all of the settings you're doing or the workflow that you've developed. And I think more importantly, you can share this, right? You're going to have some amazing, cool thing that's going to change the world. It'd be awful if you can't share that. So it's really important, I think, to try to put these cool workflows into scripts and share them, especially online. So Fiji supports a variety of languages. You can see down here, if I get my cursor, there's a pointer here. ImageJ macro is probably what you're most familiar with if you're not new to Fiji ImageJ land, but there are other ones that are supported. The script that we're going to write is actually going to use Python, Jython. I'm a Python developer. I think that's a lot of scientists are. And I want to show you something that's a little bit more advanced than just using the macro language, which has some limitations. Okay. So the macro language, I think it's awesome to start with that. If you have something simple and it works in a macro, great, you're done. But oftentimes there are things that you want to do a little bit more complicated. But don't shy away from the macro language. Check it out. We're going to look at the macro recorder. So we did that quick thresholding with blobs. We can do that all as a macro. In fact, you can see that I've done that here. If you want to know what all the built-in macro functions are, check out the documentation on the original ImageJ website here, or the original ImageJ documentation, which I have linked down here. So it's well documented, it tells you everything you need to know, and you can do some pretty sophisticated things in it. So how does one go about writing a macro? How do you discover doing that? I've already mentioned this a couple times. That's the recorder. So we'll play with this. You'll open up the macro recorder, and you can start clicking around in things, and you'll notice that the macro recorder will start to populate and collect all the different things that you're doing, which you can then copy, modify, put that into a file, and then run it on your samples. So how do you do that? So the first thing you want to do is open up an image, which we will, so don't worry about that. In this case, in this example, we do a Gaussian blur, and then you select some things. It'll do that, and it'll populate. So that's kind of redundant. After you create the macro, you can hit the create button, and it'll make a file for you. And after that, you can do things like batch mode, which is after this. I'm going to show you this first after that. So here you can do batch mode, right? So now you have that macro. You can paste it into here. You have input and output. So batch mode is for like you have a folder of images. So maybe you're going to be cropping, right? So you've done the macro recorder to crop, but you want to crop on 10,000 images. So you just put the input directory, output directory, here's your macro, and then you give it some basic details, and it does its best. This is kind of limited, okay? So, you can't do too much with it, but if you're doing some simple stuff, the batch processing is really, really helpful. So here's an example of batch processing, and we have examples that you can play with inside Fiji. So let's look at the macro recorder. Let's do a couple things and see how that works. So I'm gonna move this out of the way and clean up our little windows here. Okay, these are useful. So here is that first channel that we extracted before, fifth. So let's go ahead and open up the macro recorder. There's two ways to get to it. I believe it's under plugins, yeah, macros and record, right? So you get it that way. Or if you aren't comfortable yet, definitely get used to the search bar. So if I just type recorder, oops, record, there it is, record, there it is. Then I get the recorder. So the first thing you'll notice here is that you can select some different languages here. I had it set to Python. I'm going to select macro, and you can see that it populates a file name for you, so you can go ahead and do that. Not all the languages are supported, just so you know. You probably will just do macro. So I'm going to very quickly just kind of do that Gaussian blur thing on this, and or I'll just blur it and do some stuff. You can see that the macro recorder is going to capture my inputs. So if I go to process, filters, Gaussian blur, and let's go ahead and apply that. Sure. It's going to do some stuff. And so boom, you can see it's done that. And then maybe I want to crop right here. And I'm going to hit Control-Shift-X to crop. And you can see that it's done that. Right? So now I can hit Create. Or actually, I don't even need to do that. I could just copy this. And, oh, here it is. I hit Create, and it populated this window here. Look at that. So now I'm going to close this. We don't want to save that. And open up the original image, get that first channel out. I'm going to hit Run, and it's going to do that blur and that crop. Split channels. All right. Don't need this guy. Oops. So let's go ahead and run that again. Boom. There you go. Isn't that cool? So this works with plugins too. Buyer beware though, not all plugins were written super nice that hook into the macro recorder in a great way. So maybe you might find that the plugin isn't behaving. But for most of the base features of Fiji, almost certainly you can click around and then you'll get something that you can use to discover functions that you can use scripts and macros at large. Okay. Cool. So let's check to see if there's any questions. I'm not seeing any. All right, that's great. So we're gonna go back to the slides one more time. I'm gonna show you what we're gonna try to do as a script, and then in the last 30-ish minutes or whatever, 25 minutes, we'll try to whip up a quick script that isn't hopefully too hard, and then maybe we can also do some questions if people want to ask some questions. Okay. So let's get back to our slides. If I can find those. Ah, here they are. Okay. All right. So this is what I wanted to show you. So this is the last slide of my talk here. So here is a segmentation result that I've done using just classic segmentation on this data set where we're taking the nuclear and the puncta channel and only finding dots in the nucleus. Now that's too complicated to do right now in this little bit amount of time. But if you do want to see how this works, I'm going to do a quick little plug here because I can for side Java ops. Oops. There we go. So this example that we're going to do is here. Right. So if you want to check this out, install side Java ops. It's in the plugins. It's update sites. And then you can run this script on the data and then do some fun stuff. We won't do all of that today. We're going to do a minimized version where we're going to do a Gaussian blur and then try to extract some puncta from a channel. Okay. So it looks like all my stuff left. There we go. Okay. So let's go ahead and get back in this and give it a try. I'm going to load in the original data. And I'm going to clean off some of this stuff, and we're going to make a new file. And together, we're going to write a script to do some fun things. Okay, here's the data. So hopefully you can follow along. We're going to go File, New, and I'm going to change the language to Python, Jython. And I also need to increase the size of this. Sorry, it's a little too small. There we go. All right. And the first thing we're going to want to do here are add some script parameters. So I had mentioned those before, but script parameters are a great way to create a little quick user interface. So how do you know what script parameters you can do? Yeah, that's a great question, person who asked. So if we go to ImageJ.net, wow, so nice. And we type script parameters. There they are. Look at that. We have this really cool website that tells you all the different things you can do down here. So we'll do some of these things, but you can also do sliders and you can limit the range of numbers. Yeah, I'm not going to cover it all, but come check this out. So we're going to do two script parameters first. The first one is to get the ops service. So you chose to do this workshop with me, and we're using ImageJ2 or imglib data structures and not the older image plus stuff. So to do the image processing, we'll use ops. So we do #at, which is how we denote that this is a script parameter. And I would say ops service with a capital S, ops. Now I want to also get the image. So if I do #at and I say img, so that's the type of image. If you were doing something for older ImageJ, which is image plus, you would say image plus, and that would give you that. You would say imp. So then your object that you're going to play with is imp. So in this case, we'll do img. And this is optional, but I like to give it a label. So we say label, and we're going to say input image. And I often have like all kinds of other images open, so I don't want this to automatically grab the image that's right in front of me, that's active. If you don't do this, it will. But I'm going to say autofill equal false. And the name of this image is just img. So if I just run these two lines, I'll get this, which always comes on my other screen. Yeah, there we go. This guy. So there we go. So here's my input image. And now I can select what images I have open here, which in this case is just this one. Yeah, we'll hit cancel. The other things that we can do is we can add a string. So we want to capture the name of this channel for our script, right? So we'll do that. We'll do #string. And we're going to say the label equals name. And we'll just call this name. And we'll do also an integer to say what channel is this. So we'll say integer label. We'll call it, oops, this needs some quotes. We'll call this one channel, right? And then we'll say ch for channel. So if I run this again and run over to my other monitor and pull this back, now I've got these things. And apparently Chuckles was the channel name I had used at one point. So it sometimes saves your previous thing. So here we go, channel name and input image. That's nice. So now you have a nice front end for your script. Okay. The next thing we're going to do is we're going to extract this channel here. So we can do that with ImageJ ops. Let's do that. So we're going to call this VIF because that's what it is. Or maybe, you know what, we'll say, yeah, you know what, we'll do that. We'll call it VIF. That's what we want. We want the first channel. And we're going to say ops.transform because we're going to transform the image. .hyperslice view. And it's going to ask for some things here, which are the image, the axis that we're permuting, and then the channel number. So how do you know all that stuff? Where do you go? You know, that's unfortunately not a super great place to find all these informations, but the one that I like to go to is, and this is probably not the best thing, is the Java doc for this, unfortunately. So, you know, it's not it's easiest to think, or actually there's also, I'm getting ahead of myself. The best place is the Op Explorer. So if I do Op Explorer, I think it's Explorer. Mark, you're in here, so you can tell me. I always forget which one it is.
But that's for ImageJ ops, not SciJava.
Yeah, we're not using SciJava ops. We're
Oh, I'm
using
sorry.
ImageJ ops. Is it Explorer or Discover? I forget. Well, Mark will tell me and I'll type it in. We can look at that. So let's go ahead and put our things we want. The things that we want here are the input image, the axis. So images in ImageJ land are X, Y, C, Z, T. So X, Y, channel, the Z axis T. It's not always that way. The first two are fixed generally, but these can move around. But if you don't specify, it'll assume that. So that means that our axis that we want is Z, which is 0, 1, 2. So we put 2 here. And the channel that we want to extract is the first channel. But we're going to be working with humans, and no one's going to put channel 0. So we'll just say channel minus 1. And I also want to show this image. So I do #@output, and the output is going to be the image. So this is a special script parameter. You don't want a space between this. So if you put this here, it'll capture whatever is produced by the script and display it. So we're going to say it's an img, and the name of it is going to be output. And I'm going to change this to output. So we're going to go ahead and click run on this. So what we should see is that it'll extract only the first channel. And hit run. Oops. Of course, I need to tell it what to do things. So we're going to say the channel is this, which won't go anywhere, but we want channel 1. And there we go. And now you can see that it's output. And this is channel 1. Cool. So let's do, we have now a script that we can run real quick and it extracts a channel. So let's go ahead and image process it and do that Gaussian blur subtraction so that we can get a better segmentation. So, okay, so we'll call this here extract channel. Okay, and Mark had found where it is. So if you go to plugins, utilities, and then you go to find ops, which is here. You get, it loads up. Where did it go? There it is. This guy. And so here you can see all the different things you can do. So if we go to transform, I guess it's not in transform. Oh, that's right. I have to select this one. So if you only use user view, it hides some of the things. I have to make sure I have the full view on. And if I go to transform, because you're a developer now, you're writing a script, so you got to look at all the good stuff. And you go to hyper slice view, you can see what it takes here. And it tells you the inputs and outputs. So, excuse me, definitely check out that. So that is called the op finder. And I think if I type finder here, that might populate it. I'm not too sure. Okay, we won't worry about that. All right, so getting back to it, let's go ahead and do that Gaussian blur subtraction. So, you know, we already kind of did it before, right? So if we go to our other script that we did before, here it is. So we can just copy this and copy that. Go here and say Gaussian subtraction and paste that. So what this is doing, and we'll change this a little bit. We don't want this to be the output. We'll change this to be a slice. So what this is doing is converting the slice that we got, and actually that's a reserved word, so we'll call that img b for BIF. Okay, that's the BIF channel. Sorry for the confusion there. All right, so we'll change that to that, right? So now what this is doing is converting this to a 32-bit image, applying that filter to it, the Gaussian. There we go. And then we get this blurred image. And then after that, we subtract the original image, which in this case, the BIF one from the blurred one, and we get the result. And the result should be output so that we can see it, right? So we extract the image, we blur it, and then we subtract it. So now we need one more script parameter here, which is to get the sigma. Okay, no problem. We can just copy that from our other script. So this is a really nice one because you can see some other things you can do with script parameters. Right, so here we go. So now we want a float number, and we're going to call this sigma, but I can specify the style. So I can say how many decimal points I want, which is really nice. And also specify a minimum and maximum because I don't want a negative sigma. That kind of doesn't make sense in this case. So 0 is the smallest you can go. And then here you can specify the default value. So you shared this script with somebody, right? And maybe you want, they're like, they're not going to think about it, but they have to have a particular value here. You can specify that. And in fact, I do that for the deconvolution one, where the regularization factor is too much, is preset for you. So now when I run this script, oops, this one here, we should get a new window that looks like this. Here we go. And there's our sigma. And you can see it saved our last value. And if I hit OK, it should do the channel split and then have a blurred image. And you can see that we're doing something here, so it's working. There we go. Boom, look at that. There it is. Isn't that great? So now we're getting closer to what we want, which is to threshold this guy. So we'll go ahead and close this. And we're still working with the original image here. I'm not myself, extracting the channel. It's all happening with the script, which is really nice. Okay, so the next thing we want to do is apply a threshold. So how do we do that? You can imagine it's going to be pretty easy. So if we go to the op finder, which is over here, you'll see that if I go to the threshold namespace, here we go. You see all kinds of different thresholds. Most of these are the same ones you would see in Fiji when you go through the GUI. So which one should we use? We already talked about that. I'm going to select triangle. So let's go ahead and do that. So to apply a threshold, so now we're going to call this one, it's no longer the output. This is going to be our img sub. So we subtracted it. So let's apply a threshold now. And I'm going to call it img threshold equals ops.threshold. Actually, I'm going to call it output because we want to see the threshold output, right? There we go, output. We'll change the name later. What do I want to do here? Threshold, open and close parentheses. So we're saying ops threshold, and we want the triangle one. And you just have to give it, I believe, the image it wants, which is this one. Here we go. And hit run. And hit OK. And this is kind of the process, right? You're going to do a couple things, try it out. Maybe it might barf at you and say you forgot to do this or that, and you go back and adjust it. And as we build this up, we're starting to see the process. So boom, look at that. So now we've extracted a channel, we've Gaussian blurred it, subtracted it, cleaned it up a bit, we've applied a threshold that we like, and we're getting those outputs here. This is really nice. Could be better though, right? So we can do some more here. So let's go ahead and label this image. Now, what I would do if we had more time is I would do some erosion here, right? You got a little bit of this, little funny stuff. I would consider doing open, which is an erosion followed by a dilate. That might help clean this up a bit. You can also identify single pixels and try to filter those out. All kinds of different things that you can do at this mask phase to help improve your segmentation. But for the sake of time, let's imagine that this is good enough, and now we want to do some measurements on it. How do we do that? Okay, so we'll go ahead and close this. To do this, we're going to need to import a couple things from imglib2 to make this work inside Java. The first is we're going to want a table. So we're going to do from org.scijava.table import default generic table. Okay. And we'll import more things as we go, but this should make a nice table for us. And we're going to call this output now the image threshold. That's right. Okay. So let's go ahead and make a table. Make the table now. Okay. So for the table, what we need to do is make a new table. We say table default generic table. And the way this is, it's columns and then number of rows. So we want 3 columns, because we're going to have 3 different things, and 0 rows, because right now the table is empty. Then for each column, we're going to set the name. So I do table dot, set column header. And you set the column number. So column 0, which is the first column. And we're going to just say size. And that's what the column's called. Okay. So we'll do that for some other things that we want to measure here. So we want to measure the size of the puncta. We want to measure the mean fluorescence intensity, or MFI. And we also want to measure the centroid, because why not? 2. And we're going to call this centroid. So now this table is empty and has 3 columns. Okay. So before we can do any of this fun stuff, we're going to also need to convert that puncta thing into a labeling. So I'm running out of time. I'm going to try to do this super, super quick. So bear with me here. And I knew this was going to happen, but that's okay. You can go check out the other links and play with it there. See that this is spelled wrong. So let's do this quickly. So we want to get from imglib2 .roy.labeling, import label regions. There we go. And I know that we want regions. Net.imglib2.roy import regions. All right, that should be it. Okay. So here, before we do all this fun stuff, let's make the labeling. Create the labeling. So an im labeling is where each object has its own, or label image has its own value. So we'll say labeling equals ops dot labeling, and CCA, connected component analysis, is what that is. And we're going to give it the threshold. Yeah. Oh, and I do need to provide the structuring element. So should it be 8 connected, 4 connected? That's up to you to decide. We're going to do 8. So type 8 connected. There we go. And I need to import this. Hopefully I spelled that right. So let's go ahead and import that. Copy, please. Thank you. And that's a long one. So we're going to do that. Okay. There it is. It's wider. Whew. Okay, so we got that. That'll produce a labeling. We can actually see that if I do output equals labeling dot. You want to get the index image because that's where all the values are. So if we hit run, hit OK. Oops. I spelled that wrong. I did. No capital L. Clear, run. So that'll do something. So while that's still chugging along, hit OK. Please don't get mad at me. We can finish our table. So that's running. All right, so we have it. So the last thing we need to do real quick is populate the table. I'm going to do this in a couple minutes here. So we're going to extract the regions. Oh, look at that. Here's the labeling. Yep. You can choose different coloring to get unique colors on it to know that's a labeling, but I don't have time to show you. So first, we'll do label regions. And then we just give it the labeling. So we extract the labels. We're going to get a little counter for the rows. And we say for each region, I'm gonna call it R in the regions, we're going to do some stuff. So we need to create a sample. And that means for each region, which is kind of like a ROI, I want it over the original image, which is img fit. And now I'm going to add a new row because we're going to measure and add data per row, append row. And we're going to do this table.set. And we just go do the name of it. So the column is size, or the name of the column I want is size. The row number is the incrementer. And then we say ops.stats.size, and we say sample. Okay. So that's the measurement. You can find out what kind of measurements you do by checking out the finder. So I'm going to do the other ones here real quick. MFI and I, and then this one is ops.stats.mean. Oops, mean sample. And one more here, which is the centroid. So we just do that, just like that. Again, incrementer for the row. And ops, and this centroid thing is in the geometry namespace, so geom. There we go. And we need to do I plus equals 1. And then we do one more thing, show the table. Okay, how do we show the table? Well, to show the table, we're going to need to do one more script parameter. I wasn't done. And that is the UI service. So do UI service UI. Okay. So now the last thing here is I do UI.show. And we're going to call it results table. And we just give it the table. We hit run. So hopefully I didn't spell anything wrong. And this likes what I wrote. And we should get is the labeling that we just made. And then a table that has all kinds of different measurements on it for each particular puncta that is what we segmented in this image. Okay, there we go. Oh, I spelled sample wrong. Oh, no. Okay, we'll try this one more time. It's the last minute here. Okay. Oh, no. Okay, that looks okay. So we'll do that. While that's happening, I'll check to see if there's any questions. Looks like no questions. Yeah, but now's a good time to ask questions. We're kind of done here. I'll let this run and I'll poke around more. But if anyone has any questions, or would like, yeah, any comments or anything like that, I'm happy to answer them. Let's see. Hopefully this guy finishes. Oh, I did okay. Yeah. Let's see. This is exciting. Watching the memory jump. I'll do it all day. So it looks like it's doing the measurements now because it's going per row and it's iterating through all of the individual puncta and calculating the size and things like that. Oh, I have a question. Have you ever improved a macro in addition to combining several macros? Yeah, absolutely. You can absolutely write multiple macros and combine them into really sophisticated workflows, or go to the forum, forum.imagesc, and look at what other people have done. Okay, so in this last minute here, check it out. So here is our table, and here are all the data. There's 42,928 puncta. Some of them are probably not real because you can see you got, size 1 objects here. Mean fluorescence intensity, here's the labeling. And if I just very quickly choose RGB 332, then you can see all the different labels that were found in the image via this classical approach. There we go, segmenting with Fiji. Any other questions before we end our workshop? Well, if there aren't any, let me show you where you can get the slides real quick. So if you want to come back to this, so if you go to ImageJ.net and presentations, you'll see that, or search for presentations, you'll see from images to knowledge, I put this entry here, the scripting, and in there you can click slides to get access to these slides here and check out the links and the other data on your own time. And with that, I'm out of time. Thank you, everybody, and I hope you have a great rest of your day. Cheers.